Okay, so this is quite a fun one. So we've got that Planck's equation is 2 pi c squared h over lambda to the 5, and this is over 1 e hc over lambda kt minus 1, and we're meant to show as lambda goes to infinity. So for long wavelengths, this approaches s lambda is equal to 2 pi c kt over lambda to the 4. Okay, so the hint suggests that it's easier if we look at it in terms of x, which is equal to 1 on lambda. So let's say s of lambda is equal to 2 pi c squared h. Now I'm trying to get it into this form. So down the bottom, I'm going to put lambda to the 4, but that means I've got one extra lambda here, like that's times lambda. But I can actually write that as 1 on lambda on the top here. And then this is E times hc over kt times 1 on lambda minus 1. So I've written it that way just to get this in terms of 1 on lambda. So then I can write this, if I want, as 2 pi c squared h over lambda to the 4 x over e to the hc on kt x, that's times x, minus 1. And what I want to do now is take my limit as lambda gets big, which means it's the limit as x goes to 0. Because when lambda gets big, this x gets very small. So we can do limit as x goes to 0 of 2 pi c squared h over lambda to the 4 x over e to the hc x on kt minus 1. Okay, now at this point, if we want, we can use the hint further, and this hc on kt is equal to a. So a is equal to hc on kt. Or otherwise, we can go back to fundamentals, and if you happen to remember L'Hopital's rule, it tells us that the limit as x goes to 0, well, x goes to any constant, of f of x over g of x is equal to the limit as x goes to 0 of f dash of x over g dash of x. And so if we let f of x be the thing on top, we're just looking at this function now. So f of x is equal to x, then f dash x is equal to 1, g of x is equal to e to the hcx on kt minus 1, and g dash x, when we differentiate this, we end up with a thing in front of x, which is hc over kt, down the front e to the hcx on kt, and then when we differentiate 1, we get 0. So now we've got this part here. So we've got that our limit, we've still got the 2 pi c squared h over lambda 4, and then we're doing the limit of this part, which is equal to f dash x, which is 1 over this part, which is hc over kt e to the hcx on kt. And now we'll just replace our x with 1 on lambda. And this is the point where we could have done this substitution instead. We didn't have to do L'Hopital's. That was just for a bit of extra fun. Okay, so we'll replace the x with lambda, and we'll also cancel out some common factors. So we've got an h there and there. There's a c here and a c squared here. We've got kt on the bottom, which we can move up the top. So this is equal to 2 pi c times the kt over lambda to the 4. And then we've got... well, this is still the limit. We're still considering, or we could do lambda if we wanted, but actually just doing the limit x equals 0 will mean that this thing will cancel out, because we've got 1 over, we've moved this kt up here, and we're left with the limit of e to the 0. So e to the 0 is just 1. So this thing is just equal to 1. So we are now equal to 2 pi c kt over lambda to the 4, which is what we were trying to show. So hopefully that made some sense.